Tennessee Valley Visions was contracted to develop a comprehensive site layout for a proposed tennis complex inclusive of a multi-use facility, elevated walkway, and proposed retaining wall at Clayton-Bradley Academy.
The site layout consisted of locating the tennis courts, bathroom and storage structure, parking lot, retaining wall and pedestrian walkways, and a footbridge. All City of Alcoa zoning setback requirements were abided by. The tennis court design followed TSSAA guidelines, which adhere to the International Tennis Federation rules. Parking lot design was ensured to be ADA accessible, and the retaining wall and footbridge were designed to minimize further site impact. A challenge of the site layout was ensuring that all new structures were above the minimum 100-year floodway elevation per City of Alcoa guidelines.
Peak stormwater and runoff conditions were determined to inform drainage infrastructure design for the proposed tennis complex. One curb inlet placed at the southwest corner of the parking lot, 2 pedestrian trench drains placed south of 2 tennis courts, and 1 head wall placed north of the concession stand and tennis courts were efficiently placed in size in order to capture runoff. One positive aspect from the design is the bioretention pond. It effectively cleans stormwater of all pollutants and is aesthetically pleasing to players and civilians using the tennis complex.
A multi-purpose masonry structure was designed and analyzed for the use of a restroom and storage area at the proposed tennis complex. The structure was designed using TGI timber roof joists and exterior CMU masonry walls. Interior timber stud walls were designed to provide 3 interior rooms within the building. All roof connections were designed using Simpson strong tie connections. While working on this project, I gained the opportunity to better understand the overall design of structures. Through working with my mentor engineer, I was better able to understand the structure load path and how all members impact one another in the design process.
A timber pedestrian boardwalk and steel frame pedestrian bridge were designed to connect the existing boardwalk and Clayton-Bradley academic campus. A pedestrian timber boardwalk was designed according to AASHTO guide specifications for the design of pedestrian bridges and national design specifications for wood construction. A steel frame bridge was designed in accordance to the American Institute of Steel Construction manual.
A retaining wall and foundations for the new structures on the Clayton-Bradley Academy campus were designed based on lab testing of soil samples. Lab testing on these soil samples was performed to identify the necessary strain characteristics of the soil. The gravity retaining wall was designed using Ready Rock design and analysis software, and the wall borders 2 sides of the tennis complex to accommodate the new grade of the site.
Erosion prevention and sediment control measures necessary for the construction of the new complex were determined, informing development of a construction schedule as well as a cost estimate for the project. An initial, intermediate, and final erosion control plan was developed for the tennis court complex. The erosion control measures included rock check dams, inlet protection located at drains at the parking lot and tennis court, and a 748-foot silt fence running alongside the perimeter of the job site.
In my time as a CE400 student, I've learned and applied true technical skills that engineers use in their day-to-day work, but I've also learned and developed many professional skills that will help me excel in my career. To name a few, written and verbal communication, time management, and project management. My time in CE400 has challenged me greatly, but has allowed me to grow my skill set and apply it to a real project.